Hello, I'm Mary Miller, EDX and ultrasound clinical educator at Cadwell. We want to thank you for joining us today for our webinar, Buzzwords, Winning the Fight Against Electrical Noise by Wendy Sebetka. Before we begin, I want to touch base on several housekeeping items. This webinar is approved for one asset continuing education unit. To earn credit, participants must attend the full duration of today's live session. Complete a brief post-webinar survey about your experience and provide a valid asset ID number. Be sure to check your email inbox over the next several days for an email from Cadwell Education containing your survey link. Today's webinar will also include a live Q&A session with Wendy Sebetka at the end of the presentation. Please submit your questions in the Q&A box at any time. We will be monitoring them throughout the session, and we will address as many questions as we can during the live Q&A. Now, it is my pleasure to introduce today's speaker, Wendy Sebetka. Wendy is a seasoned expert with 25 years in the neurodiagnostic field. She currently serves as EMG Application Support Specialist at Cadwell, where she continues her passion for education and support. Wendy's clinical background spans from EEG, NCS, IOM, and PSG, with focus on nerve conduction for much of her career. She holds registries in both NCS and EEG and has spent years teaching medical professionals and technologists in neurophysiology. She is also a dedicated member of AAET, having served in leadership roles, including president and examination chair. Please join me in thanking Wendy for leading today's session. Wendy, I will now hand it over to you.
Thank you, Mary, and thank you all for attending and allowing me to share my knowledge with you while we all join together to win the war against electrical noise. A few disclosures to start off with. I'm a current employee of Cadwell and past president and committee member of AAET. I want to begin with some basic electrical principles. Understanding these basic concepts is key to effective troubleshooting. Without this foundation, it's much harder to identify what's working, what's not, and why. While the majority of my clinical background and focus of this discussion will be on nerve conduction studies and EMG, the troubleshooting techniques we'll be discussing can be utilized across all neurodiagnostic modalities. No matter how you look at it, everything begins and ends with an atom. The elements that comprise all matter are made up of atoms and their three particles: protons, electrons, and neutrons. Protons are the particles with positive electrical charge, electrons are the particles with negative electrical charge, and neutrons are just that, neutral. Protons and neutrons bind in the center of the atom to create the nucleus, while the electron orbits around the outside of the nucleus. All elements are unique and are defined by their anatomic arrangement. Coulomb's law tells us that like charges repel and opposite charges attract. The process of electrons flowing from one atom to another is how electricity is created. The electrons orbit at such a rapid rate that they are unable to resist the ability to be pulled together by the opposite charges. Electricity is generated by the movement of electrons from one atom to another, and they can move in the form of either current or voltage. Current is measured in amperes and is the instantaneous movement or flow of electrons from one atom to another. When similar atoms are aligned in a row, the electrons are bumped from one atom to the next, causing this chain reaction of electron flow. Voltage is measured in volts and is the electrical potential difference between 2 points. This difference between 2 points creates a force that drives the electrons to reach equilibrium. Current can flow in either a direct or along an alternating pathway. Direct current is the flow of current in one direction. Typically, this is thought to be from negative and positive, though depending on your source, one may say it is the other way around. Batteries or anything battery operated, including lighting, static electricity, and personal computers, are common examples of circuits that use direct current. Alternating current can flow in either direction along the circuit. This occurs due to a repeatedly reversing of directions that is created by an electromagnetic force in electrical generators. The speed at which the current alternates is the frequency and is measured in cycles per second, or as we're familiar with, hertz. Here in the United States, we use 60 Hertz, though other countries use 50 Hertz. Common examples where alternating current is used are in electrical outlets and non-battery powered electronic devices. Most electronic equipment uses a combination of both AC and DC. Resistance is measured in ohms. It is the inability or difficulty for the current to flow between the 2 points. The amount of resistance depends on the material being used. All natural materials have some form of resistance, though the amount depends on their anatomic structure. The flow of electricity along a circuit depends on the resistance. Circuits flow in ohms. Circuits follow the Ohm's law principle that we're familiar with. E equals IR, or voltage equals current times resistance. Resistors are electrical devices that control the amount of electricity that flows through a circuit and can be set up in either a series or parallel fashion. Resistors in series have no choice but to flow along the circuit via each of the resistors. The more resistors it goes through, the higher the resistance. Resistors in parallel have many separate circuits, which gives the current the opportunity to follow different paths. The current always follows the path of least resistance, and the smallest current goes through the largest resistors. In the situation of a parallel circuit, adding resistors reduces the overall resistance. Conductors and insulators are key in the electrical transmission process. Conductors are materials with low resistance, which allows the electrons to pass from one atom to another, making electrical transmission easy. Metals like copper, aluminum, gold, and silver are all good conductors. Insulators are materials with high resistance, which will not allow electrons to pass from atom to atom, blocking the electrical transmission process. Air, glass, plastic, rubber, and wood are all good examples of insulators. This information is important to us because it reminds us that electricity is everywhere. Whether it be as an insulator or as a conductor, all matter has some degree of electrical properties. The EMG machine uses an alternating current source to generate a direct current stimulus. The stimulus is applied through 2 poles, a negative or cathode pole, a positive or anode pole. The stimulus evokes a response which is filtered through a differential amplifier that measures the potential difference between the negative and positive inputs. We refer to these negative and positive inputs as our active and reference electrodes. Ground is an electrical term that refers to earth. Our ground electrode provides a low resistant pathway from the machine through the electrical outlet into the breaker panel, which is then connected to an underground metal rod. Since electricity always follows the path of least resistance, when excess and potentially hazardous currents are introduced, the ground helps to achieve equilibrium between the positive and negative charges by giving the excess charges a safe, low resistant path to the ground, preventing the infiltration of unwanted signals from flowing out through our recording electrodes. Earlier, we discussed resistance. In the neurodiagnostic lab, we refer to resistance as impedance. When impedances are high, we must reduce the resistance in order to maintain measurable responses. Our human bodies also function on these basic principles. I like to think of our nerves as wires, muscles as light bulbs, and stimulus as a switch that turns it all on. When a shock is given, negative and positive potentials are introduced to the neuron, activating the depolarization-repolarization process that provides us with a great deal of information in regards to how the body's electrical system is working, though that is not without risk. To protect our patients from the inherent risks of an electrical shock, the FDA regulates the amount of stimulus we can give to 100 milliamps or 400 volts. The consideration we have to make in the neurodiagnostic lab is that the electrical potentials we are interested in are significantly smaller and much more sensitive than the signals found in a typical environment. Any infiltration of outside signals creates electrical interference or noise. Noise is any unwanted disruption or distortion of the true electrical potential we are trying to elicit. These signals can be generated by electromagnetic electromagnetic fields of energy from an electrified wire or energized circuit by radio and television signals that are transmitted via wavelengths of electromagnetic energy. Electromagnetic fields of energy will induce a voltage in adjacent wires or circuits if they have nowhere to go. They can present through our machines. This interference can present as large, consistent, sinusoidal, or spiky, disorganized artificial potentials. When dealing with noise, there are generally 3 steps we take. The first and most important is prevention. If we can prevent it, then the rest is a moot point. The second step is troubleshooting. This is where we will spend most of the remainder of our discussion today. And the third is managing the artifact in a way that allows us to still do our job without eliminating the source of the issue. Prevention. So how do we prevent the noise? All systems are required to follow FDA or international regulatory guidelines during the development process. These guidelines include regulatory body testing, specifications, and recommended techniques for shielding and reducing noise. Special consideration goes into ensuring shielding techniques are used during the amplifier and cable design process to allow external signals to be blocked or filtered out. It is pertinent that we follow the manufacturer recommendations when setting up these devices. This includes computer and hardware configurations. Machine grounding is often discounted, especially by traveling customers who frequently set up and tear down their devices, but is not a configuration that should be overlooked. Lack of proper grounding creates a playground for external signals to present themselves. All machines and testing supplies come with recommended maintenance and cleaning instructions, which you should abide by to promote safe, long-term, issue-free operation of the system. Using an unapproved cleaning solution and exposing devices to physical stresses such as dropping the unit or exposing it to extreme temperatures could cause harm to the device and should be avoided. Our Cadwell systems have a recommended annual preventative maintenance schedule. Information regarding these topics can be located on our help files under the service and routine maintenance section. The default machine settings are configured by the manufacturer based on their testing and calibration methods. These are not interchangeable from system to system and manufacturer to manufacturer. Even though EMG and IOM devices both use similar types of testing, using the same settings is not viable. The machine settings allow the collected data points to be viewed and measured in an accurate, consistent manner. Altering these settings changes the visual appearance of the waveform, and in some cases, it also alters the data measurements. While it is relatively safe and common to adjust the sensitivity, time base, and in some situations, a 60 Hz filter to provide the users with a better visual experience, this is not true for the low-cut and high-cut filters. Adjusting the low-cut and high-cut filters not only alters the visual appearance, but it will also alter the data point collection and your final outcome. Decreasing the low-cut filter will decrease your amplitude and increase the latency of the response. Adversely, increasing the low-cut filter will increase amplitude and decrease latency. Decreasing your high-cut filter will increase amplitude and latency, while increasing the high-cut will decrease amplitude and decrease latency. Changing these from the default settings should be done with caution and only when necessary for a specific purpose, such as research. The best method of handling 60 Hz interference is to locate the source and eliminate it. But when that is not an option, the 60 Hz or notch filter can be very beneficial in reducing 60 Hz noise for sensory studies and as a last resort for EMG. The 60 Hz filter should never be used for motor type studies, and this will filter out necessary parts of the waveform and alter your responses. Another key to preventing noise is using appropriate supplies. All supplies should be FDA approved. FDA regulations do change, so it is important to stay up to date on these regulations. While it is not required, it is suggested to use supplies that are recommended by the machine manufacturer, as these are the supplies that have been through testing and validation processes. Shielded cables, like the ones shown on the slide, have an extra conductive layer around the wires to protect against electromagnetic interference and can be helpful in preventing noise. If using reusable electrodes, gel with a conductive property such as Spectra 360 or Electron 2 is a must. Ultrasound gel is great for ultrasound, but it does not contain the conductive properties necessary for nerve conduction study and EMG testing. Machine filter settings are the part of the prevention process that's handled by the manufacturer. The rest is up to the facility and end users to ensure they are creating an electrically quiet environment. The following guidelines should be used to create this electrically quiet environment. End users should work with their facility electrical engineering team to ensure the earth ground is properly connected. A properly installed earth ground gives excess signals a low resistance path to follow. The earth ground is a metal rod or pipe that is a minimum of 8 feet long and is buried at least 30 inches deep and below the frost line. According to the National Electric Code, the standard earth ground's resistance should be under 25 ohms. However, in medical facilities, the resistance level is often recommended to be at or below 0.1 or 0.2 ohms due to the sensitivity of the devices. Ground resistance testing can be performed by an electrical professional using a ground resistance or an earth tester. Maintaining proper cable management by refraining from rolling the machine over the cables, neatly wrapping cables, avoiding kinks in the wires, and using Velcro strips or zip ties to secure wires in an uncluttered manner will protect your wires from non-visual damage. Any additional cables will increase the risk of noise entering your system, but when necessary, only medical-grade surge protectors and extension cords should be used. Mechanical beds have the potential to act as a ground or an antenna. Wooden beds and carts are preferred, but if they are not available, it is important to ensure the cart is properly grounded and plugged in or unplugged based on the system's response. Lights are a common source of noise and can easily be determined by turning the lights on and off. Blown bulbs or lights that have not been securely tightened in the sockets can be a new source for noise. All electrical devices emit signals that can infiltrate our responses. Special attention should be paid to remove all unnecessary devices from the area. This includes additional medical devices such as ultrasound machines, heaters, warming devices, fans, refrigerators, and even cell phones and chargers. The question of installing a Faraday cage always comes up when talking about preventing noise. If considering installing a Faraday cage, you will want to perform a cost-benefit analysis to ensure the expense is worth the benefit. You will want to ensure the proper cage is selected, taking into consideration the frequencies you need to block, as high frequencies require a smaller hole size, while larger frequencies would require a larger hole size. Installing the incorrect option could lead to no improvement or even worsening of your noise. Cage installation should always be completed by a qualified professional to ensure there are no gaps in the construction, which could allow leakage of unwanted signals that would lead to an increased instead of decreased level of noise. Prevention has failed, so now we'll troubleshoot. The first step I'd like to take in troubleshooting the noise is recognizing what type and where the artifact may be coming from. Troubleshooting shock artifact is a much different process, so identifying this early on will prevent unnecessary steps and increase the time to resolution. Noise artifacts can arise from non-physiological sources such as computers and lights, or physiological sources stemming from the body such as sweating or movement. Identifying the location of which artifacts are originating from where will guide you on your troubleshooting mission and help you to identify the cause and eliminate the source. Shock artifact can be easily identified by appearance. Shock artifact occurs at the beginning of the sweep prior to, or in extreme cases, overlays the expected waveform. It is important to remember some shock artifact is necessary, and we do expect to see that at the beginning of the study, but it becomes an issue when seen in excess. Eliminating shock artifact is generally done by using proper stimulation techniques. These include properly cleaning the stim probe to prevent buildup of excess gel, applying firm, steady pressure, properly prepping the skin and removing any moisture or debris, and using appropriate amounts of conductive gel, making sure not to create a salt bridge. Decreasing the pulse width of the stimulus and slightly angling the anode may be a beneficial technique in swinging the baseline and improving the response. In rare cases, a failing stim controller or e-stim controller may cause this issue. Visual inspection of the noise will allow you to make some mental notes of the details of the waveform pattern. Does it look spiky? Is it consistent? Maybe it's disorganized. Is the baseline straight, flat, or fatter than I'm used to? Visual inspection of the noise can be helpful in giving you a direction to work with. In most situations, your live monitor is going to be your friend and will provide you with real-time feedback as to whether or not your troubleshooting techniques are successful. Some important details to make note of regarding the noise relates to the timeline, consistency, and test protocols affected. These details will tell you a great deal of information about the noise and how to troubleshoot it. Ongoing intermittent issues that occur in all test protocols are typically more difficult to resolve as compared to new replicable localized issues. It is a common misconception that reusable electrodes and wires last forever and don't need to be replaced. After multiple uses, unseen damage may have occurred and replacement is inevitable. Even with increased frequency of disposable electrodes, we shouldn't discount our electrodes as a cause for noise. Expiration dates should be noted as the gel on the electrodes may deteriorate, decreasing the integrity of our electrodes. The purpose of the gel is to increase the conductivity between the surfaces. To maximize this effort, it is imperative that you are using non-expired gel that includes conductive properties. In today's day and age, we also need to take into consideration recent computer changes such as Microsoft and software upgrades or hardware replacement. While the potential may be low, being aware of these changes may play a key role in helping us resolve these issues. The first thing to consider is making certain proper electrode management techniques are being followed. The easiest step to take when trying to eliminate noise is to replace the electrodes. Replacing the electrodes will resolve most new consistent noise issues. The next steps to take would include ensuring the electrodes are secure and accurately placed as mentioned in the previous slide. Confirming the electrodes and gel are not expired is always recommended. If 60 Hz noise is a concern, a larger ground electrode should be used to increase surface area for the excess potentials to be directed down. If you are using reusable electrodes, performing an electrode continuity test on the amplifier can assist in determining the integrity of those leads. The electrode continuity test is performed by plugging the electrode into the isolated ground input and placing the metal electrode on the metal pole just above the input. If the electrode is good, an audible tone will play and the lights on the amplifier will change from white to blue. Noise occurs due to an increased potential difference along the circuit. Removing extension cables reduces the amount of available surface area. Likewise, twisting your recording electrodes together decreases the distance between the poles and eliminates additional opportunities for infiltration. The next items to consider is environmental factors. To help with identifying the source, we should do a quick mental review of our environment, making note of anything that may have changed. Changes that can be seen visually, such as a plugged-in heating pad, or a cell phone on the charger are of course the easiest to recognize, but many environmental factors are unable to be seen. A fluorescent light that's not securely connected or the new heater that was added to the office next door are also culprits of noise and should be thought about. When troubleshooting ongoing intermittent issues, it's especially important to make note of the overall environment, not only being aware of the items in the exam room, but also adjacent areas and even structures that surround the general area of your building. Included in the overall review are the details regarding the patient. Initial observation of your patient should have been made while rooming the patient. Skin type and level of cleanliness should be assessed so proper skin preparation techniques can be used. If you've ever heard me lecture before, you may recall me saying, I have a love-hate relationship with alcohol. Alcohol is a great way to prep the skin, but one must use caution as it may also clean your electrodes, causing deterioration of the stickiness or the gel, creating additional issues. Pumice scrub is a good option if you need to clean rough, dirty limbs. As we all know, patient comfort is an important part of the successful patient experience. A comfortable patient is able to be relaxed and maneuver their extremities as appropriate for the designated study. Tense patients create muscle artifact, which can interfere with our traces. When troubleshooting issues, it is important to have confidence in your machine. Routine maintenance and proper care will ensure system integrity and provide you with this reliance. We have discussed that having electrical devices near your system can be a source of noise, but we also need to consider that our device itself is an electrical source. Having your amplifier too close to your base unit or your power cord draped over your amplifier is directly exposing the device to electrical potentials that will likely introduce excessive signals. Properly installed ground wires will allow excessive signals a place to go. All cables should be connected securely with appropriate connecting devices and neatly wrapped. The power cable should be directed away from the equipment rather being wrapped around near the base unit or amplifier. When necessary, shielded cables, hospital-grade power strips, and isolation transformers may be successfully installed to help successfully reduce the noise coming into the device. Troubleshooting the environment can be as easy as flipping off a light switch or as difficult as having to seek out an electrical engineer to test the integrity of your earth ground. When troubleshooting through environmental concerns, unplugging all unnecessary devices one by one will allow you to rule out or localize a concern. Temporarily turning the lights off or unplugging devices will provide real-time feedback regarding the contributions to that particular device. Just because power outlets are in the same room doesn't automatically mean they're on the same circuit. Switching outlets, especially to one with a dedicated ground, should be trialed. If you're not familiar with how to locate a dedicated ground outlet, they are usually distinguishable by the red outlets, an orange triangle, or a green dot on the outlet as shown in the image on the slide. If a complete review of the environment is not successful in determining the cause, the use of a noise detect probe may assist you in locating the source. Obtaining a noise detect probe is preferred, but if one is not readily available, you can download an EMF detector app on your phone for quick access. Before we continue, I'd like to take a quick moment to review the troubleshooting techniques we discussed. Electrode management includes swapping out electrodes and ensuring they are secured and appropriately placed, twisting active and reference electrodes together, and checking expiration dates for disposable electrodes and gel. Performing an electrocontinuity test is a good test for reusable electrodes. Machine and cable management should include proper positioning of the machine and amplifier, securely connecting cables using the appropriate connectors, neatly wrapping excess cables, and making sure the power cord is directed away from the device. When possible, eliminating extension cables, even if they are hospital grade, is ideal. Patient management techniques include skin preparation, proper patient position, and ensuring the patient is relaxed will improve the outcomes of the study. Stimulation management should include stim probes are clean and free of dried up gel. Applying firm, steady pressure to the patient will not only improve stim artifact, but is much more comfortable for the patient. When using conductive gel, use caution not to use too much to create a salt bridge. Troubleshooting of 60 Hz interference can be difficult, but unplugging and eliminating unnecessary devices or swapping power outlets one at a time can help locate the source. If further investigation is needed, reviewing adjacent areas and using a noise detect probe may be necessary. The use of the 60 Hz filter is also available as a last resort. Next, we will review some noise examples and work through some thought processes as we troubleshoot each scenario. When looking at sample number 1, I make note of the excessive unexpected deviations from baseline. The waves appear to be a bit disorganized. I don't really appreciate any spiky waveforms or a consistent sinusoidal appearance. These characteristics lead me to believe that this artifact is coming from a physiological source. Because of that, a review of my patient is performed. Patient was noted to be very tense and was asked to relax, and the baseline flattened out and the response was elicited. This issue was resolved by asking the patient to relax, and the better study was completed. Key points of sample number 2 don't show any spiky, disorganized waveforms, but it does look very consistent and sinusoidal in appearance. These details lead me to suspect a non-physiological source. The recommendation was made to extend the amplifier away from the machine and closer to the patient. The artifact was eliminated and a cleaner response with a more defined onset was able to be obtained. The third sample was a new issue that started after successfully completing 5 previous studies that day without issue. I make note of the excessive unexpected deviations from baseline, the disorganization, and possibly some spiky components. With the information I have, I can't feel comfortable narrowing the source down to either a non-physiological or physiological origin at this time. So I performed the previously discussed troubleshooting techniques, starting with the easiest, which is electrode and patient management. Patient and electrode management techniques were performed, and it was noted that there was lotion on the patient's skin that was causing the disposable electrodes to not adhere securely. Alcohol was used to prep the skin to remove the lotion, and tape and gel was used to secure the electrodes. Electrical noise was resolved, and adequate waveform was able to be obtained successfully. Scenario number 4 was occurring intermittently, but has now progressed and is a constant issue. Again, we notice excessive unexpected baseline activity. The waveforms are blocked, but there is no impressive sinusoidal component. The blocky appearance leads me to believe this artifact is coming from a non-physiological source. Electrode and patient management techniques failed, so we proceeded to the machine management techniques. Machine settings were configured to use a different channel and the issue was resolved, confirming this specific scenario was an issue with the DIN connector. Alternate channel was continued to be used until the amplifier could be sent in for repair or replacement. Sample number 5 is a new artifact that started this morning. The user is reportedly a traveling tech working from home who is trying to make some edits to their system, but they are unable to obtain regular responses because they are getting so much noise. Initial appearance is blocking, consistent, and sinusoidal, making me suspicious of a non-physiological source. Since this issue has not been an issue in the previous to this current setup, an environmental review was performed. In this case in particular, the tech had their amplifier sitting next to their coffee warmer, which I don't really recommend, but that was the scenario. Amplifier was moved from the source and issue was resolved. In the clinical lab setting, it's more common that we see heating pads or other warming devices be left plugged in while warming the patient, but the 60 hertz noise presentation is the same. Sample number 6 just started today. Key points of this waveform note spiky, sinusoidal, consistent waves. Looking at the sample, I'm comfortable assuming this is coming from a non-physiological source. Further investigation determined a reusable electrode that had not been replaced in several months or even years. Electrode management troubleshooting techniques was implemented and the old reusable electrodes were replaced with disposable electrodes with wire and issue was resolved. When using disposable tab electrodes, you should also remember to replace the alligator clips frequently as well. Sample number 7 is a new issue. Everything appeared to be working fine a minute ago, and then another coworker was brought in to review the current study. The spiky, consistent sinusoidal waveform has me thinking a non-physiological source, but the ticking aspect of it has me thinking physiological, maybe a pacemaker or spinal cord stimulator, though it wasn't there a little bit ago, so that still leaves to be questioned. Patient history determined that there was in fact no pacemaker or spinal cord stimulator in use. Since this issue was not present a few moments ago, an environmental review was performed and no was made to any changes. Further observations of the area determined when the coworker came in to review the study, they sat their iPhone down near their system. The iPhone was removed from the device and the issue was resolved. It is important to note that while in this instance the phone was right near the device, this can also occur if the iPhone is in a pocket or being used. My observation has found that Android devices are not as bad as iPhones. I suspect this may be due to the iPhone design where the antenna wraps around the outer edge of the phone, pulling in more signals. Sample number 8 shows an artifact that is consistently occurring prior to the generated response, and at times it often obliterates the waveform. A quick observation recognizes this as stem artifact, though it is in excess and has the potential of altering the waveform measurements. Shock artifact can be from either physiological or non-physiological sources. Review of this situation's skin condition did not raise a cause for concern, so I was comfortable troubleshooting through the non-physiological sources. Stimulation management troubleshooting techniques were applied and the pulse width was dropped and the issue was resolved. When managing shock artifact, you will also want to consider the intensity level, proper use of gel, adequate stim pressure, and ensuring the stim probes are securely connected. Sample number 9 is our final sample and has been an ongoing issue reported by the physician. Key observations note a consistent sinusoidal appearance with superimposed small rhythmic spikes. Again, I suspect this to be a non-physiological issue in nature. As the first step of troubleshooting, all electrodes were visually reviewed. Visual inspection of the ground electrode was reviewed, and the wire was not only visibly frayed at the neck, but also has multiple tight knots causing kinks in the wires. Ground electrode was replaced, and issue was successfully resolved. Most noise issues are able to be resolved using these troubleshooting techniques. But what do you do when they don't resolve these issues? Then we have to manage it. The keys to managing noise include following good cable management techniques by using zip ties or Velcro strips to bundle and secure loose cables, Routing cables along designated pathways and eliminating excessive length when possible will prevent unnecessary disorganization and damage to the wires that could be caused by kinks and pressure on the cables. Following the guidelines for proper technical techniques for patient preparation, electrode placement, and stimulation will reduce the factors of technical error. Frequently replacing electrodes, using larger ground electrodes and shielded cables, use of gel with conductive properties, and abiding by expiration dates should not be overlooked when dealing with an electrically charged environment. Using filters such as 60 Hz notch filter will reduce or eliminate 60 Hz interference when all other options have failed. The use of a noise detect probe may be helpful in locating the source of the noise, providing further information for how to minimize the effects. Adhering to the manufacturer's recommendations for maintenance and care of the equipment will provide successful long-term operation of your device. And last but certainly not least, it is imperative that you are aware of the environmental factors that may be contributing to the noise concerns. In some cases, facilities are located near active construction sites, radio station, and large power lines. Eliminating the noise may be nearly impossible. At that point, if relocating is not an option, properly managing what you can will allow you for the best probability of success. In summary, it is important to understand that electrical properties are present in all environments. Being knowledgeable about the factors that contribute to a noisy environment is beneficial in eliminating them as possible. Being able to recognize the source using the live monitor and based on the visual appearance of the waveform will speed up the troubleshooting process by preventing application of unnecessary troubleshooting techniques. Knowing how to apply the troubleshooting techniques as related to electrode, stimulation, patient, machine, and cable management. When all of those fail, understanding that some noise may not be able to be eliminated and having these expectations will help you manage the environment and perform successful studies. This concludes my discussion today. I would like to thank you all again for allowing me to share my knowledge with you, and will now switch you back to Mary Miller, who will provide you with some necessary information.
Thank you, Wendy, for sharing your insights with us. Now we are going to transition into our Q&A session. If you haven't already, please share your questions in the Q&A box below. We have about 10 minutes or so to answer questions live, and we will try to get through as many questions as possible. If we are unable to get to your questions during the live session, we will follow up with you after the webinar ends. Wendy, you should be able to see about 3 to 4 questions in the box below in the Q&A, if you'd like to begin.
Okay. So the first question, is there a difference in noise detection between disposable versus non-disposable electrodes? My answer to that is no, not really. In my experience, we've tried to do some comparisons with disposable versus non-disposable, and if they're good, viable electrodes, then then it's generally about the same. Sorry, I'm reading through these here. The next question says, was it said there was a phone app for noise detection? Yes, the answer to that is yes. It's kind of, it's actually, if you look it up, it's called EMF detector. And a lot of the apps are noted for ghost detection. So if you look up ghost detecting app, it will also pull up the same thing. The next question is, how do you reduce or minimize the stimulation artifact for cranial nerve MEP in the OR? I've had experience in the OR, not extensive, so I'm going to just kind of answer that very generally. sticking with those proper stimulation techniques, ensuring sometimes you have to use a lower duration with a little bit higher intensity. Sometimes it's the other way around. So adjusting you're also need to take into consideration in the OR the other technical factors that come into play. Apologize for that. I'm not super super up to date on my OR noise issues. The next question, why do we get artifacts in the neuromonitoring machine when we connect the return electrode and do not get artifacts when we remove the return electrode? I'm going to show me connect the return electrode. If we can clarify, are we, for the return electrode, must be just talking about the reference electrode? So one thing I would recommend is replacing that electrode to see if that electrode is damaged in some way. It could just be that it's a damaged cord. Sorry, there's so many questions in here. I'm trying to get with some of them that will answer like the best. So so the question is, what do I do if the customer doesn't have proper grounding? So if the machine is not properly grounded, I would suggest to add one. If we're talking about environmental grounding, then that would be to, my recommendation would be contact an electrical contractor who could then come in and install an electrical ground for you. The earth ground is something that can be added later and is able to be installed. So that my recommendation would be to see if your electrical team would be able to install that ground. The next question is, does the length of the electrode cause artifact? And that answer could be yes. So the longer the lead you're using, the more surface area and the more opportunity for responses to infiltrate your response. So yeah, if you're using longer leads, that is definitely a cause for concern. The next question there is there any experience with recording electrode wires contacting the stimulator or temperature probe wires with causing 60 Hertz artifact? I have seen this, yes, where that does happen. Sometimes it's probably due to unable to be seen break in the wire or something of that nature. But I have seen situations where those outside electrical sources are trying to exit through those other cables. So if there is a contact made, then there is the opportunity for that to be exposed in our studies. So next question, can I run the machine without earth grounding? It is not recommended. You can run the machine. You're probably just going to experience a lot more of those, that outside interference, that 60 Hertz noise and things like that. Earth grounding is definitely going to be a big factor in cleaning up your responses. The next question here, what is the ideal way to tie active and reference cables to avoid artifact? I've seen a lot of people put knots in them, which again, if you do make a knot, you really don't want to do it tight because you don't want to pull it. I've seen them be braided together. You can also take a little piece of tape or something and put them around them. I think mostly you just want to be sure that if you are kind of tying them together, you don't want to pull them snug and enough that you're going to damage the wires. I actually prefer to just kind of tape them together so that they're together, but we're not damaging the cords. Next question is, assuming the machines using the same electrical source with ground and only one machine is working normally without noise, the other two machines' hardware problems or grounding issues. The place where I would start with that is grounding. If the other machine is working as expected, there's something going on with that specific those other two machines. It could still be an environmental factor based on where those other two machines are located, but I would definitely start with reviewing the grounding of those devices. Recommendations on managing electrical interference when performing nerve conductions and EMG intensive care units with multiple electrical appliances going on. ORs and ICUs are very difficult environments. A lot of those systems or a lot of those other devices that are working can't be shut off. Like you just can't shut off a vent. So, I mean, that's counterproductive of why we're there. So generally what we would try to do is if there's something that we can unplug, we unplug all of those devices we can. A lot of times the bed can be unplugged, the bear huggers can be unplugged. If the bed is on a rotating cycle, then that can generally be stopped. Some other tips for that is when you're stimulating, try to position things in a manner in which you're distancing yourself from the patient and like the bed. So for instance, if you're trying to do a Searle, if you can lift the leg up off the bed and not have the point of contact on the bed and on the patient, that can be helpful as well. Otherwise, just those environment management techniques, trying to follow those as much as you can, given what you're given. Otherwise, some of it you just have to manage. Next is about adjusting filters. If we adjust the filters, sometimes it affects the waveform amplitudes as well as latencies, and it may have ended up with the wrong results. So what's your recommended filter settings? My recommended filter settings are always to go with the default ones from the machine. Those are the settings that the system was tested with, and that's what is recommended. If you don't know what those default settings are, you can either download a default preserve file and take a look at those there, or you can email us or call us and we can help you figure out what those should be. How do we make our baseline more stable? Making the baseline more stable is kind of putting into play all of these things that we've been talking about. We want to be sure we have good patient management. We want to be sure they're relaxed and comfortable and have done good skin prep. When it comes to the electrodes, we want to be sure that we have good electrodes that are eliminating as much noise as possible. If you're using ultrasound gel, lots of people use ultrasound gel because they don't realize that that ultrasound gel doesn't have conductive properties in it. Using electrogel can really make a huge difference in how straight your baseline is. If you're doing sensory studies, you say stable baseline, I'm kind of making the assumption that it's just electrical in nature here. So you can try to turn your notch on, see if that works. Otherwise, work through all of the troubleshooting techniques that we discussed. Um, Is there a difference between noise detection? Oh, I already answered that one. Sorry about that. Versus disposable and non-disposable electrodes.
In the open questions,
Okay.
I've
And
dismissed
then,
anything that you've already answered. So if you look
okay.
at open, those should be the
Okay.
ones that.
Okay. So, for a mobile device, how far should be kept from the EMG machine? So I think you're asking how far the patient should be away from the EMG machine. Generally within, it's okay to have it within 2 to 3 feet away. There's really no generally set rule about how far away that device should be away. If it's causing an issue and you're getting noise, try to move it around. So sometimes moving the cart to the head of the bed will make it better. Stretching the amplifier over to the towards the patient will help. And if you have other questions, or if you're moving it around other areas like towards a power outlet, sometimes you're going to want to move it away from those items. Oh, and I see that the question about the return electrode. I apologize for that. I'm not familiar with that return electrode in a surgical unit. I'm so sorry. We'll have to get back to you on that one. And then next question, how could we reduce interference in EP studies when the impedances are very low, the rejection is minimal, but the recording still looks very noisy? With this, I would say that one thing with impedances is that they can be low, but if there's a difference greater than about 5 in your impedances, then even though you're under 10, that can cause a lot of artifact. So ensuring that your impedances are all within 1 or 2 or 2 or 3 of each other is going to help you eliminate that noise. Also with the EPs, there are some other settings on the system that will allow you to change the rate of rejection as far as how many are rejected. So those are some things that you could look into altering to see if maybe your rejection rate is set too high.
We have about time for one more question.
Okay. Let's see if I can find. So question, can the use of 1020 paste replace conductive gel? I would not recommend this because 1020 paste is a little bit different. The consistency is different, and it does have the conductive properties that we want, but it's just a different structure, and it's the consistency would make it difficult to properly use.
Thank you, Wendy, for leading today's session. We appreciate your insights on BuzzWars winning the fight against electrical noise. I also want to thank everyone who joined today's session. We appreciate you sharing your time with us. As a reminder, please look forward to the email from Cadwell Education with a link to the post survey in order to earn your CEU credit. If you have any questions about today's session or you're interested in scheduling a demo with a dedicated representative, please reach out to marketing@cadwell.com. Have a wonderful day and thank you.